Hello class, we're looking at a homework problem in MyOpenMath from section 8.2, and 8.2 is making or producing confidence intervals for a proportion. And regardless if we're making a confidence interval for a proportion or if we're making a confidence interval for a mean, the procedure has the acronym PANIC. And so if you look at the homework problem, PANIC, that's a reminder of the procedure to find a confidence interval. And it's PANIC, P for parameter, A for assumptions, N for the name of the procedure, I for the interval and the point estimate, and then C for our conclusion. Okay, we'll go back and read this problem. It is believed that 11% of all Americans are left-handed. So the problem begins off by giving us a proportion. It's actually a population proportion because of the word all. Okay, so the population proportion, little p, is evidently 11% or 0.11. In a random sample of 500 students, so that is our random sample, little n is going to be 500, from a particular college with 50,096 students. So notice that is going to be the population. The population is specifically just this particular college, and capital N is 50,096. They found that 66 were left-handed. So the number of successes, if they asked the question, hey, are you left-handed? 66 said yes. So little x, or the variable, how many people out of 500 said they were left-handed, and how many? 66 said that. Find a 91% confidence interval. So there's our confidence level is 91% for the percentage of all students at this particular college who are left-handed. So we'll start with capital P, which is the capital P in the word PANIC, and the P stands for parameter. What is the correct parameter? Well, it's definitely a population proportion, and it's definitely going to be the proportion of students at this particular college who are left-handed. So little p, and the wording is going to have to be percentage or proportion of all students from this campus that are left-handed. Okay, so the parameter is little p, and little p stands for the percentage of students at this college that are left-handed. Assumptions. All right, so for assumptions, we have to verify that NP hat is bigger than or equal to 10, and 1 minus p hat is bigger than or equal to 10, and 20 times the sample size is less than or equal to the population size. All right, so we've got those three conditions. Now, it isn't enough just to state the conditions. We do need to verify. Oops, and I forgot a part here. Since we have qualitative information, qualitative meaning number of people that are left-handed, and left-handed is qualitative. So it's going to check. So NP hat, and I'm going to go down and check with my calculator. NP hat is really just the number of successes. We had 66, but so 66, that's going to be the number of successes. So N times P hat is the number of successes here. So that's 66. And so I'll enter 66 in here. And I'm going to have to switch this over to that. And that is definitely greater than or equal to 10. And minus 1 p hat, that's the sample size minus the number of successes. So if we had 66 that were going to be, in fact, left-handed, then it would be 500 minus 66. So this would be 434 would be not left-handed, and that is still definitely bigger than or equal to 10. So notice I'm using kind of a little clever idea here. you could figure out what p hat is, which is x over n. But x divided by n times n is just x. So n p hat is x, meaning the number of successes in the survey. The number of successes is 66 people left-handed. 66 is bigger than or equal to 10. Well, if 66 people were left-handed, then of course 500 minus those 66 individuals would not be left-handed. And of course that's bigger than or equal to 10. The population of this particular college was 50,000, and I'm going to have to scroll up to see. 50,096. So I'll move that to 50,096. And that is definitely bigger than or equal to, and I just pass it, 20 times the sample size. And 2 times 500 is 1,000, but so that means 20 times 500 would be 10,000. But in case we weren't confident, let me clear this. 20 times the sample size of 500 is definitely 10,000, and 10,000 is less than the population size. Now, if a problem does not give the population size, ours did, then just use here 1,000,000 is our population size. But our sample was 500 and our population size was 50,096. So we don't have to worry about putting a made-up number here. Name of the procedure, and it's going to be 1 prop z interval. 1 proportion z interval. The reason I said 1 prop because that's what it looks like in the calculator. Okay, so that's the name of the procedure. The interval and the point estimate. And so now that's where I'm going to actually go to my calculator. And it's stat, calc, and go to tests, and then 1 proportion z interval. And I'll scroll. Oh, I just passed it. There we go. Select that. And the number of successes, 66. The number in our sample, 500. The confidence level, well, I see short-term memory. I'm going to have to go look at that. The confidence level, 91%. So I'll go to my calculator. Of course, I'm not going to enter 91. I'm going to enter the decimal version of 91%. And now I'll hit calculate. All right, so it gives us the actual sample proportion, 13.2%, or 0.132 as a decimal. And this is the confidence interval. All right, so let's see if we can't use this information over here. And I'm going to move this to half the screen, so we can still see the calculator at the same time that I've got my homework up here. All right, so the point estimate, that's p hat, that's our sample proportion. Leave as a fraction, well that's nice, I didn't even need the decimal, but it was 66 and divided by 500. And I'm not even going to reduce this. Well, at least it doesn't say I had to reduce it, so I'm going to leave it like this. Leave answer as a fraction. If you wanted to reduce that, we could reduce that to divide both by 2. I'd have 33 2/50ths. So I'll go ahead and reduce this. 33 2/50ths. Now let's just say you're just not confident in reducing this. I'll show us how to reduce that in a second on the calculator. I'm going to go ahead and type in the confidence interval here. The interval estimate for P, right? We're not doing an interval estimate for P hat. P hat's right here. We're doing the interval estimate for the actual population proportion. And they want 3 decimals. So I'm going to have 0.106. Look to the right of 6. That's the 3. So I'll just leave it at 0.106. For the right side of the interval, it's 0.157, but look to the right of 7, it's a 6, so I'll round up to 0.158. All right, now be careful because, maybe another problem will say round to 4 decimals or 5 or 2, so be careful and make sure to read that. I did want to make sure that we reduce this correctly, so I'm going to go ahead and hit second quit on the calculator and enter 66 divided by 500. And there's the 0.132. That's the decimal version. It did want it as a fraction. So if you hit math, and the first option is fraction, you hit math and hit enter, it will just take that decimal and convert it to 33 2/50ths, and well, that's what we have. All right. So our conclusion: we are 91% confident, and so 91% confident. Again, that's the confidence level that was stated at the very beginning, that the percentage of all students from this campus that are left-handed is between, let's see here, 10.6%. Notice I'm converting the 0.106 into a percent. And 15.8%. All right, and so that completes all of the entries for our problem. Looking over one more time. Again, the fraction might stump us, but our calculator does that for us if we hit the fraction button. Let's go ahead and hit submit. And hooray, all of the answers are correct. So this completes the homework problem number 1 for section 8.2.